Hi and welcome back. This is the second video of two sample inference procedures with means, aka matched pairs, on chapter 25 in AP Stats. Alright, so we ended off on this slide here. Let's go on to our next part. Let me move forward here. And again, you have our less than, greater than, or not equal to, just like before. And please be careful with your greater than. It still means that you will have to do your complement, and your not equals is your answer times 2 for both tails. So let's move on. Our hypothesis test is next. So the formula here is not any different than what we've had. Our test statistic is a t, and our statistic minus the parameters divided by our standard deviation is here. So we have x bar d minus mu d divided by sd divided by the square root of n. And again, this deals with matched pairs. Since this is a test statistic, we do have to take care of our degrees of freedom, and again, that is n minus 1. All right, so let's take a look at an example. This is question number 18 in the text. So, having done poorly on their math final exams in June, 6 students repeat the course in summer school and take another exam in August. If we consider these students to be representative of all students who might attend this summer school in other years, do these results provide evidence that the program is worthwhile? So here are some data. What I need you to do is use your calculator. Go ahead and enter your data in Stat Edit and put June in L1 and August in L2. So you can either pause the video or go ahead and do that. I'm going to assume that that part's done. Again, you're putting June in L1 and August in L2. Okay, let's talk about our parameters, our hypotheses, and then go through the gambit of what we're supposed to do to solve. Mu sub d is the true mean difference in scores between June and August for students who repeated the course in summer school. Our hypotheses, since this is a one sample mean, and we'll get to that in just a bit, and one sample mean, because we're finding the difference in them, our null hypothesis should be that there is no difference. Our alternative shows that there is, and that in fact, our mean average is greater than 0. All right, so let's go through our assumptions. The first is that it must be a paired and random. So think about what the situation is. Let's go back to that. Do you see how it's the same student's grade? You have the same student's grade in June and you have the same student's grade in August. So that is why it is a matched pair. It is a paired set of data. They are randomly selected, as it said it was randomly selected, and the samples are from the same student, so they're paired, and we'll assume the sample differences are random sample of the population of differences. The sample distribution, when you look at your graph, go ahead and take a look at, go to stat plots to make sure your stats are turned on, and choose a histogram to see what that looks like. And when you press graph, you may have to mess with the window or zoom stat it or zoom fit it and take a look. But your data should be approximately normal. If you go to second stat plot and actually turn your stat plots on and look at the normal graph, the very last one, option 6, if you go ahead and look like that and go ahead and press graph, you should get a graph that looks like this. Now take a look at what your box plot looks like to see if we have any outliers. So when you go to your box plot, again, go to your stat plot, and the type, choose option 4. But before, I think we're going to have to do something with our list. Yeah, I think we will. Go to stat. You know how you entered in L1 and L2? Scroll over to L3. Scroll over to L3. And actually go into where it says L3 and highlight L3. And when you highlight L3, what I need you to do is take L1, so second 1, minus L2. No, other way around. L2 minus L1. Yeah, I think that will give us the number values that we want. Yes, exactly. So scroll up again to L3 so that you're highlighting the L3 in the third list. And you want to type in L2 minus L1 and press enter. The very first value should say -4 in that list. So what I now need you to do is take a look at that box plot of L3. So go back to y equal, or second y equals, go back to your stat plot and cursor over of your type and go to option 4. Down where it says X list, I need you to type in L3. You should have a frequency of 1. And then when you push your graph, you take a look at what your box plot looks like. It should look something like this. So this tells us that it is approximately normal. There are no outliers. And the first graph here tells us it's approximately normal. It's nearly linear. So the normal probability plot, this one here, the normal probability plot, is fairly linear. And the box plot shows no outliers. So we will assume that the sample distribution of differences is approximately normal. And lastly, the sample should be less than 10% of the population. The population should be at least 60 students. We chose 60 because we have 1, 2, 3, 4, 5, 6 differences, and we multiply that by 10, which we will assume. So since these conditions are met, we can then go ahead and do a t-test. So in this case, we do not know sigma. It is not given in the problem, so we do not know it. And we are doing a t-test for matched pairs. So here's our calculations. Go back to your formula. I'm going to leave some blanks in there. We're actually going to get them from the calculator. Our formula that we talked about earlier, we have some math to do. So once you go ahead and do this, we're going to go to stat cursor to test. We're actually going to do option 2, a t-test. We are going to use our data. Mu sub 0 is 0. Our list is L3. Our frequency is 1. We are doing a greater than, and we're going to calculate. So we should have, our t-value was 1.7541. We are only looking at a greater than. Our x bar is 5 1/3. And our s sub d is given as 7.4456. Although this should be a 6 here, but that's okay. We round to the 4th decimal place. And alpha is 5%. So a t-value of 1.7541 gets us a p-value, as it states here, as 0.06988. So what does that tell us? It's greater than. So what decision do we make? Our decision is to fail to reject. Do we have sufficient evidence? No. There's not sufficient evidence to suggest that the true mean difference in scores is different from June to August. this suggests that the program may not be worthwhile. So that is an example of a matched pair problem. We will have many more in our homework. I hope this video helps.